Good morning, good afternoon, good evening for wherever you are watching and in whatever time zone. I have the distinct pleasure and honor of introducing my next guest. We met over the phone about a year ago. He has now become friend, brother, and compatriot in this endeavor in STEM education, as well as the many things that he is doing at IBM. This is my friend, Naeem Altaf, who is an IBM Distinguished Engineer and the CTO of Space Tech there. He just, I think a couple of weeks ago, he told me, celebrated his 20th anniversary with being with IBM. And during his amazing career, he has led IBM's Blue Tech Innovation Group. He is innovating like edge computing in space to supply chain optimization for space assets to autonomous cognitive frameworks for CubeSat swarms. Who has that on their resume, I might add? To growing challenges of space debris and collision avoidance, geospatial analysis with satellite imagery, to exploring quantum computing, which I think we would all wish that you could get here sooner than 10 or 15 years from now. And he is opening up new realms of possibilities for the new space age. His team partners with various space agencies, universities, and space tech companies to design and build a first of a kind proof of concept and technical prototypes. He's been leading work for IBM in collaboration with NASA and SETI for the Frontier Development Lab. He also leads technical client engagements in building public, private, and hybrid solutions for IBM. He's not busy at all. He has a deep technical knowledge of systems, applications, and industrial asset monitoring and management, and he's a visionary in so many more ways than one for a smarter planet, smarter infrastructure, industrial solutions, and pioneering concepts for the Internet of Things. And I can't tell you what a joy it is to introduce you today as we talk about advancing space and advanced computing. So tell me a little bit and everyone about what you have been working on and what you're most excited about.
Well, first of all, thank you, Janet, so much inviting me on this amazing forum. So, good morning, good afternoon, good evening to everyone at this wonderful Explore Mars conference. So, IBM, as you know, has a long history with space industry. 50 years ago, we created these mainframes, which helped send men to the moon, and all the Apollo missions, the landing of the first astronauts in 1969. It's still ranked as one of the greatest engineering achievements in human history. In addition, we also have been involved with the Hubble telescope, the Space Shuttle era, the supercomputing, which is used by NASA. So we have a long history. So our group, the Blue Tech Innovation Group, which was formed earlier this year in the beginning of 2020. And we started with, there were 3 or 4 areas which we wanted to innovate in. The first one was this build is cognitive autonomous framework for CubeSats. So as we know, in going forward, there's a huge push for these satellites for doing different things. The easy one is like the Earth observation. The satellites of the past, as you know, they are sort of, the way we think of monolithic, huge, several hundreds of $1 million, it costs to do that. But with CubeSats, a very, I think, fancy one, you can get it for $1 million, but universities and students, they are building for less than 100K. So this is a huge, innovation happening in this space. So what our focus was that we build this framework and we will see these swarm of CubeSats going up, right? So basically, instead of a big monolithic satellite, we will have these, let's say, a fleet of them, like 13, 15, 18 of these CubeSats in the space. And they act as distributed computing. So, for example, like just last week, this hurricane Laura, which came towards the south part of US, right? So let's say these swarm of CubeSats are in the orbit, and one of them detects this hurricane 3, 4, 5 days before it starts hitting, the lands. It tells all of these CubeSats to start focusing on this event, and based on there will be different algorithms which we are building inside. So basically, it's looking at who has the capacity and who has the right amount of sensors to tackle this event for next 7 days. So let's say you have 13 CubeSats. Out of 13, 7 will create this sort of a logical cluster, and they'll start focusing on this event.
Hmm.
And this is fully autonomous. They are, deciding among each other who gets to, do what job, and they can all work totally independently. So there is no like a concept of a master and a worker node. They're working independently. So that's the framework which we want to give it to the world. It will be open source tomorrow, and we will have lots of yes. We've been working on this for almost last 3-4 months now, day and night. So yep, this will go live tomorrow evening on the IBM's GitHub, public GitHub, and we want the universities and schools to collaborate with us to take this framework to the next level.
And
So
can you provide that website? I might get you to send that to me so that I can put it up for everyone. Why did IBM decide to do that open source?
So IBM is big on open source. I mean, the value of open source. The idea over here is to get the developers to create awareness, right? And especially for the STEM, which you are so active, Janet. You do an amazing job for STEM purposes, right? How can we get more kids, the underdeveloped countries get involved, give them access to this, and they can start developing on these frameworks, and hopefully, in next decade, they all will be launching their own CubeSats. So it's the bottom here is to create the awareness for the industry and get more people on board, developers and kids.
I just think that's fantastic. When you're talking about that swarm, I think of,
Yes.
I'm thinking about, again, I get that you've got that bird reference there. So is it AI? Because you're saying they're talking amongst themselves. So
Yes.
there's nobody on the terrestrial ground telling them what to do, but they're doing it autonomously. How does that happen?
So yes, so of course the AI is in the heart of all of this, right? And then the mesh network, basically the intercommunication between these CubeSats in a swarm. So the way it will work is, so like I said, CubeSats, they have all these fancy, sensors, cameras, infrared, all this watching, doing Earth observation. So one of those sensors detects this event, and these CubeSats are loaded with different models for image analysis, right? So that's one way where it detects an event and it starts creating formation of let's say, a cluster, which is a virtual cluster. And then from there, it starts working on that image analysis and trying to send data information below. Or it can make a request, or we can push an alert from down. For example, from our weather stations or weather channels, we get the alert saying that this event is happening, and we send this alert all the way up to the CubeSat, and from there on, it takes over and starts doing what it's supposed to do. But there will be, yes.
No, keep going.
Yes, so there will be algorithms preloaded, but there will be more algorithms which will be built and which you send over to the CubeSats to go and take. And this also goes into, we'll talk later on about the edge computing. That's what edge computing is, right? You're doing processing autonomously right where the source of data is.
Do you want to talk at all about an upcoming project that is doing an autonomous boat? Do you want to include that and let people know about that before we jump to that next question?
Yes. So there is if you all can just Google Mayflower autonomous ship. So this is in the, to commemorate the 400th anniversary of the Mayflower ship, which went from the Plymouth, UK to Boston port. So there is this autonomous ship. We've been working on this project for 2 years. It will set sail in the harbor the second week of September. It was supposed to go all the way, but because of COVID, now I think it's delayed till next year. But we will have our sort of a dry run inside the harbor, and basically fully autonomous, and it's using the satellite communications to send the telemetry data and other interesting things it's learning as it will be going across the ocean. So yep, so we have done all the data integration work behind how data comes into the cloud, and we will make this data available for everyone, especially for the STEM purposes. Yes.
And what I find is there's such an application from going autonomously sailing and making a voyage to
Yes.
autonomous space travel as well.
Yes, and to add more, Janet, there's like two more topics in this stuff you're doing. One is around the space situational awareness, space traffic management, and space debris. These are all interrelated. So, to date, we had like 5,500 rocket launches and close to like 9,000 satellites in space. But as you guys all are watching, right, even yesterday or 2 days ago, SpaceX launched another fleet of satellites, right? So all these Starlink satellites which are going up, so there will be like close to, I think, 20 to 30,000 in next 2 to 3 years. So there's a lot more stuff will be in our orbits, right? So what we are looking at is, because it becomes very critical that we know we have better identification, tracking, and sharing of this information. Because think of this, right? So in your airspace, if the plane is traveling from Austin to, let's say, New York, right? Uh, you have one path it shows you on the map in your flight tracker. What if that flight tracker showed you 4 different paths? It will be a very bad thing, right? Because you don't know, your controller doesn't know which one to trust. Same challenges are happening in the space. So we need better identification of these objects which are in the space, because we will be having lots of launches in the next decade. So we need to understand, so we don't, accidentally something comes in the path. So
Mhm.
that's one area, and this framework of space situational awareness, where you can detect the conjunction between the two objects. We also open source this whole code. It went live last Wednesday, so it's already available now. So you can go on the UI and you can ask for which two of these objects are coming closer within, like, 100 kilometers in next 7 days, and it will show you, list everything. So I will again share all this information after this call.
Uh,
Yeah.
and I think that you have literally come up to the next obvious question is,
Yes.
how is all of this in space and commercialization and tech? What are those intersections of space exploration, commercialization, and where tech is?
Yes. So, I mean, first of all, the most important thing is, right, the space is no longer like restricted or limited to the national agencies or the military, right, or the contractors. It's expanding rapidly, and thanks to the private commercial companies like SpaceX and others, right? So these technology advances by the private commercial sector, it's it's challenging the historical practices done in the space industry. For example, reusing the rockets, right? Building these efficient spacecraft, performing these cheaper launches, right? Having these rideshare opportunities. For example, in the space shuttle era, to launch 1 kg, it was around $19,000. Today with SpaceX, it's 1,900. So you can imagine how drastically the cost has came down, right? So it's a paradigm shift between the public and private partnerships. And then 3 months ago, we all witnessed a historic moment when there was a partnership between SpaceX and NASA, taking the astronauts to the International Space Station, right? And that's the first one. I think the next one is coming up in a month or so. So I think these, and then NASA opening up the ISS for private tourism. So these all things are, right. I mean, opening up a whole new world of space economy which did not exist before, and hence, like they say, democratize access to space for all, right? Also, in this run, right, in the past 6 months for the Artemis mission, going back to the moon and beyond 2024, right? This program, we are seeing again a lot of public-private partnership happening, where the human landing systems are awarded: SpaceX, the Blue Origin, and there was another company, I think Dynetics. Then Astrobotics, which will be using a lunar rover. Then there's intuitive machines finding some dark spots. So there's a lot of stuff happening in this commercialization, and I think it's a good thing.
It's a very good thing. And
Yes.
when I sit and listen to you explain all of this, I just keep thinking about the generation that is coming up now and future generations, that there are jobs that we have not even created a name for in tech. Would you agree?
Yes. Totally agree. Yes.
And so how does that, it's like in preparation for this, like the most advanced technological generation that's ever been,
Hmm.
how is that? I mean, how else are you seeing kind of like the preparation for tech and how space, and where are those models for like even making life on Earth better as you develop these technological things for space exploration?
Sure. So there are multiple areas, right, which will emerge, and more will emerge as we make more, more exploration, expansion, and technology advancements. So the first one, which I see like starting from like sort of low hanging fruit in this area, right, which can be done today, right? For example, the first one is edge computing, right? So we are hearing, probably everybody's hearing a lot about 5G networks, right? And 5G networks is going to literally explode edge computing on the ground. What it means is that you have very fast networks, high bandwidths, and basically you are doing computation right where the data is being produced. So, for example, everybody, because of now in their homes, right? Imagine you have these very powerful, dense compute sitting in your neighborhood, which is serving you Netflix, Zoom, all the entertainment, right? Which is we are watching in the house through the internet. And that means it doesn't have to travel all the way to some data center or to some CDN networks, right? It's sitting right in your neighborhood. So you can imagine the bandwidth, the speed, and the quality of the stuff you will be watching, right? And so basically the basics of edge computing, like I said, is to take compute to where data is. So we don't want the network latency, right? We don't want to move enormous amount of data. And when we are talking about edge computing in space, so all these satellites who are doing Earth observation, I mean, they are collecting tremendous amount of data, as you can imagine, right? And right now, I think I read it's like the resolution is down to 10 centimeter, right? That is amazing what they can see all the way from from the lower Earth orbit. So there's some enormous amount of data which they have to push down to the ground and then do analysis and then make it available. What if we have these smart algorithms which can take some of that load, do right processing on the satellite itself? And that's where I think we will have to come up with very smart deep learning neural networks which can run on these, because we don't have the compute power as we have on the ground on these satellites, right? So we have to be very smart in how we minimize the footprint of these models and run on these edge computing sites. The
So,
second thing, yes, go ahead.
yeah, no, go ahead, because I'm gonna bookmark my question. Keep going.
Sure. The second thing is related, which is the IoT, Internet of Things, and satellites. So again, like you mentioned, right, there's a huge amount of advancements in the satellites from all the way from Earth observation, from the global positioning, right? And a lot of scientific breakthroughs have been done. So, for example, from Earth observation satellites, you're looking at the aquatic and climatic aspects, terrestrial environments, via spatial, spectral, temporal, and radiometric. These are all different kinds of imaging techniques which are happening, right? So now you imagine, like for example, like I said, combining this with the edge computing, right? You have these CNN or these convolutional neural networks, right, which you can push all the way on the satellites. And in case of a natural disaster, floods or earthquake, something that happening, you need to get that information quickly to the first responders. And not only that, but also you need to show them which are the areas which needs the help most, right? So in combination of sensors on the ground and the remote sensing, in this case happening from the satellites in combination, this will be a huge thing going forward. And we will see a lot of this happening because 5G networks are on the ground, you have the satellites on the top, and combining all that data at a very high speed. And so we can solve these problems.
Can we have it today? How
So
soon?
yeah, we can. I mean, there is, like, for example, there are lots of startups which are emerging. So for example, let's take a look at the in the agriculture area, right? So where you don't have the telephone networks or the broadband networks there. So what you can do, you can have a gateway set up which has these sensors, all over the fields. So all these sensors are collecting information like the soil moisture and all different kinds of aspects, and they send this to a gateway, and then this gateway is sending information to the satellite, and from there it goes into a data center. So that's one way of, in all these remote areas, you can collect information from, and then you combine that ground information with the satellite imagery. And there are, companies, as you probably know, like Planet and Max are doing amazing job of doing Earth imaging. So in combination of that data with the ground data, that's how we're going to solve the problems up next.
This is, to me, it's like it's an area that I love listening to about, and the more that I listen, it's like I get this much more conversant in your world. But I realize there is sort of a mandate for all of us to begin to become more technologically minded, learn about these systems, learn about how they're, I mean, you guys are working with different kinds of cloud computing and all these things that are really going to benefit, storage and internet bandwidth, how we access things, how quickly. I mean, to me, the most amazing thing, Naeem, is that all of a sudden we can have friends instantly all
Yes.
over the world. How do you
Mhm.
think that kind of shapes what is your hope for how that shapes humanity?
Well, definitely hope for the best here, right? That everybody is connected, and we have interconnected world which we have today because of all things around. You see through these web conferences, web meetings, everybody can see each other, right? You have the social media, so but we need to have we need to do for the good. We need to have what matters is all this data which is being produced in this which will be produced right with these 5G networks, internet of things. What is the insights we can get from this information, from all this data, because there is so much noise out there, right?
Mhm.
What we need is a meaningful information which can help, which can benefit people, and especially in the underdeveloped countries, right? How can
Mhm.
we lift them up? Because the next challenge, huge challenge which is coming, will be this water in the droughts, right? How can these technologies, or because that is the most important thing for us, for humans, right? And how can we preserve that in the future, right? And then in this context, right, COVID-19, which is happening right now, right? Okay, so this morning I checked, we are like how much, 7.5 billion people on the planet, right? I'm sure it went a little bit up since then. And so yesterday I was reading that they are saying we might need two shots for COVID-19. Okay, so times that two, so you're looking at 15 billion shots now, vaccines, right? Imagine when this will be released in whatever, whenever, hopefully soon, but let's say in next 6 months, right? This thing gets released. How do you track that? How do you make sure that it's equally distributed and not the privileged one get hold of everything, and then you know what happens after that, right? So this is where I think blockchain, the remote sensing, the Internet of Things, they all will come together, right? How can we track every single of this vaccine, right, as it will move around the globe, right, to make sure that everybody gets the equal right to access that vaccine. So I think this is where I think again, like I said, you can watch the Earth at 10 centimeter resolution. Let's put it for good, right? Let's come everybody together and help the world in next 12 months so we can come back to the normal phase.
I think that is our shared hope that through science, through technology, through space exploration, that there it can be a uniting of humanity, that we are trying to do the most good and push these things forward. You're going to love this next question. Daniel has been asking amazing questions all day. How will quantum computing play a role in Mars in the
Yes,
Mars
yes.
2033 mission or 2045 mission, whenever we get to Mars? Quantum computing in Mars. I bet you could talk about that for a bit.
Sure, yes. Okay, so quantum computing, right? It's amazing. I mean, you read about it and you just wonder, what will the world be in next 2 decades when this becomes, available and accessible. So quantum computing, as you know today, it's a nascent technology, right? But it will revolutionize in many industries, including the space industry, right? The complexity, as you know, in our data is growing, right? So we have a huge amount of data sets, and so much data is being produced literally every minute, right?
Mhm.
How can we work through this data? And like I said, how can we find that insight, that nugget inside of data? And quantum computer, where it will help, will be like there are 4 or 5 areas from IBM point of view which we are looking. 2 areas over here. One is optimization, and the other one is, of course, AI and machine learning. These are the 2 areas which I see going forward from the space in general, right? So, for example, the Mars rover, which just went up, right? So, one of the goals of this rover is to drill at I think, 30 different locations to find the samples, right?
Mm-hmm.
This is a perfect use case for quantum, right? How do you optimize? How do you find, place where to drill? Because probably it's a limited things we can do in that with that rover. So we have algorithms built for the optimization, like a quantum amplitude estimator, which can take a look at this. Then the other area which I discussed earlier was this space, the collision in space, right? Now think about, let's say you have like more than 250,000 debris, which is around 10 centimeter, right? Plus all these satellites. If I have to figure out the probability of one hitting each other, right? This is where the quantum computing comes into picture. So that's another area where it will be where if we want to go and start doing some cleaning in the low Earth orbit, right? How do you optimize that? What's the shortest path, right? This is where another area where algorithms like maybe quantum sport, vector machine, QSMVM can help. And the another area which everybody can also relate to is the spacecraft trajectory optimization. But that is a that is a huge challenge, right? Even the supercomputers of today, I mean, it takes them time, right? But once we have quantum, the first step is to get to the quantum advantage in next 10 years, which means that this computer can calculate things faster than the computers you have on the planet. And then there is this quantum supremacy, which is far away, right? That is where it will be. We can't even fathom what it can do. It will be like it just scares me what it will be able to do in next 30, 40, 50 years, right? But yeah, these are the areas: optimization, AI, and machine learning. And by the way, if anybody, I highly recommend, this upcoming generation, right? Go and learn this stuff. IBM has made quantum publicly available. You can just type IBM quantum computer Qiskit. It's free. Go. We have the tutorials. We have the toolkits. Everything is available. We just ran a class this summer free worldwide, and it was a huge success. So I really say that the next young generation, go and learn quantum computing, because that's the future.
It is the future. I know you're going to supply those links. We'll do that. Let me it's like, I love this question. Is Everetts Theory involved in what you're talking about? Does it work by having enough information so you can accurately calculate where that object will be? So it's Everetts Theory. Are you familiar?
No.
So Pedro, again, it's like that's like these are things that again we love asking these questions and learning something. You know what, Pedro, you've made me do? I'm going to go look up Everetts Theory. So
Me too.
In our last moments together, we're going to supply all the students with links where they can find this on IBM and really just congratulate your company and tell them thank you, because a future pipeline and coming behind you with all of the engineers that I'm sure you will mentor will be the technicians of tomorrow. So IBM making that available is quite wondrous. Here is another question about that CubeSat swarm. Could it be designed to monitor weather on Mars? If we find Ingenuity with its completely, crazy speeds of RPMs with those rotor blades, is there a way for these CubeSat swarm to monitor things, dust storms on Mars?
I'm sure it can, because the satellites, which I think, so the two orbiters went one from UAE and one from China. They both send the orbiters to go and study the atmosphere of Mars, right? So these are, of course, larger satellites. Of course, we can, have the smaller CubeSat form, and depending upon what kind of the sensors we put on, yes, definitely.
Any last words? What is your hope for Mars and maybe for the students of tomorrow?
Yes, so I think this is a great question. I think we all, people who love space, and humans in general, right? We all have been fascinated by space, right? We have been searching for, not we, but in general, the scientific community, searching for life on the other planets in our solar systems and beyond, right? For many years. And then the concept of interplanetary travel, right? That's that's the dream. So I think all this technology advancement. Look at these gigantic telescopes going up in the South America in the next 5 years, right? All this technology just gives me a lot of hope, right? That that we have a huge, there'll be amazing things happening in the next decade or so, right? And just like I said, and recently 3 missions went to Mars, 3 countries, right? UAE, China, and US, sending orbiters and the rovers over there. So, and also like from the previous Curiosity rover, we learned about the atmosphere and the conditions on the ground on Mars, right? That there is water there, used to be, right? There's ice over there, so it has all the ingredients for life, but there are major challenges, right? And yesterday when Elon Musk was talking about, right, people were asking, everybody is very interested to know how Starship is going to do, right? But he clearly said they will have several flights of satellites before actually putting human on that thing, right? So I think we are, it will take some time, but it will happen. I have no doubt that it won't happen. But the most important thing here is, right, like you said, for the next mission, these quests for these, landing humans on the red planet, or going beyond, or going and learning about all these other planets. I think it will inspire the next generation of space explorers, engineers, mathematicians, and scientists, right? And that's how we create our group. In our innovation lab, we believe that sky is not the limit. Thank
The
you.
sky is not the limit, from Naeem Altaf. Thank you so much. And again, thank you for your generosity. Hopefully in the next year or year and a half, we'll see how this goes. We're going to announce a great challenge in the realm of CubeSats with Explore Mars and IBM. Again, everything's been a bit affected by the year that is 2020 and I think what we were talking about privately before our chat began, is that this is a call to action. This paradigm shift we can embrace, because now we understand connectivity can happen in this way, where we may not have opted for this before. And so as we evolve as a society and planet, embracing new waves of technology, adapting to what is, and then pushing hopefully the best and most good forward. But the sky is not the limit. Thank you so much. Please send me those links. I'll make it public for everyone. And again, thank you, my friend.
You're most welcome. Thank you so much, Janet.
Bye, guys.
Bye-bye.
And in just a moment, I think what's coming up is that we're going to have another great panel. I'm sure the team may have a video. I'm going to hop out of this conversation and over to another one. But again, guys, thank you so much. We'll be back with you very shortly. Bye, guys.
Thank you. Thank you.